Welcome to your introduction video on quadratics and parabolas. Quadratics is a form of an equation or expression, and parabolas are a shape. Shape is a parabola. You've probably seen it before. Any object thrown on planet Earth will follow this kind of path. It's called a trajectory, and the trajectory is always parabolic because of gravity. All right, first of all, you need to know what quadratic expressions are. These are quadratics, these are not. If you take a close look, all of these have one variable, in this case x, here's a w, here's an m, here's a y, and the highest exponent on the variable is a 2, so x squared is the highest thing here. Also here x squared, here's w squared, m squared, and y squared. All right, it's not a quadratic if the exponent is bigger than 2. So here's a cubed, a 3, that's not a quadratic. Here there is not a 2, it's only a p to the first power, so that's not quadratic. Here it has x squared, but it also has y. When there's two variables, it's not quadratic. Here it has a power of 4, no good, and then this has no variable at all. So what is a parabola? A parabola is the shape created when you graph one of these expressions as an equation. So a quadratic equation has this form. We just talked about that. Y equals ax squared plus bx plus c. Remember the x squared, the a, b, c are just coefficients or numbers. And when it's written in this form, this is called standard form. Later we're going to see a different form. A, b, and c are constants, it says, so just some numbers, and a is not 0. If this was 0, then you would have no x squared. It would no longer be quadratic. So a must be something other than 0. And it says, in other words, the highest power is a 2. Well, that's what we've talked about. So quadratics have a 2. So this is a quadratic equation, and a parabola is the shape made when you graph it. So here is the reason quadratics and parabolas are so important, again, is because in our world, everything that flies follows a path that is a parabola because of gravity. Gravity is pulling the object back down to Earth. So there's a basketball shot, there's an arch. I'm not saying that this was formed in this shape because of gravity, but it is a parabolic shape. All right, here's a famous bridge in my hometown of San Francisco. Notice this shape here on the suspension line is parabolic. It's also a parabola. Even evil things like McDonald's and these poisonous foods they're putting in our bodies have examples of parabolas. There we have a double parabola. And here, this famous arch in St. Louis, Missouri, USA, this arch is a parabolic shape as well. And again, basketball shot. Great, so a couple things you're going to practice today. First of all, you need to recognize what the A, B, and C values are. These are all written out. You need to rewrite it in standard form, and then you need to say what the values of A, B, and C are. For example, the first one, it's not in standard form because the x squared thing should be written first. So now I've rewritten this. The x squared thing, which is negative x squared, goes here, then 3x, and 4. This is now standard form. Your A value is the coefficient in front of that, which is actually a negative 1. The b value is that value, 3, and the c value is that value. We've used these letters when we've been factoring, so you should be used to this. So now, what are the a, b, and c values here? All right, hopefully you got 1. B is 0 because there's actually no x term, and then c is negative 5. And the last one, what are the, I'll write it in standard form, and then what are the a, b, and c values? So standard form looks like this when you expand this, and then when you multiply the 3 through there, you end up with standard form right here. And in standard form, we see the a value is 3, b value is negative 6, and c value is negative 45. All right, the other thing you have to practice today is just graphing parabolas. So if you're given an equation, you should be able to fill a table of values and then plot the points and make your parabolic shape. When you're graphing this one, first we're going to put an x value of negative 3. So you put negative 3 in here. Negative 3 squared is 9, minus negative 3 is like adding 3. So 9 plus 3 is 12, minus 2 is 10. So that's 10. Maybe it's difficult for you to do that just in your head. If you need to write it out, do write it out and practice that skill. But here's that one, and that point can be graphed on here. So now try to fill in these points, or get a value for all those points, and then we'll check your answers in a second. All right, so hopefully you got these values. Double check all yours. If one of them is wrong, try again, see what happened. All right, and now let's plot those points. So here's negative 310, here's negative 2, 4, here's negative 1, 0, and so on and so on. There's all the points. You connect them, they make a nice parabolic shape. We have our parabola. Important things you should notice in a parabola, there's things that are going to be key for our work with these. First of all, this is called an x-intercept. It's where the parabola hits the x-axis. This is the x-axis. There are always going to be two x-intercepts. Well, or maybe not. So there's two x-intercepts there. This point is called the turning point, but it's also called the vertex. So you'll hear both used. Vertex is probably a better word. And here's the y-intercept. So again, the parabola hits the x-axis twice here, but it hits the y-axis. This is the y-axis. It only hits it once right here, so that's called the y-intercept. So make sure you know there's two x-intercepts, a y-intercept, and a turning point, or the vertex. Those are the key points on a parabola. So there you have it, introduction to quadratics and parabolas. Please try the short assignment that follows this video just to practice these skills. You can do it.